So last time, tell me the roots that we found. I think they were called UVW, right?
Mm-hmm.
So our U is
Negative 7 pi over 18.
no.
Oh.
Alright, so
12 power 1 over 6.
12, 1 over 6,
Exponential 5 pi over 18i.
5 pi over
18i.
18i. V,
12 power 1 over 6.
hold on. V is 12 1 over 6,
Exponential negative 7 pi over 18.
Negative,
Yes.
okay.
7
7 pi over 18i, and W, 12 1 over 6 again.
Exponential 17 pi over 18i.
Yeah. So these are the three roots that we found out, right? So now I say by considering the sum of roots, they just need you to apply the Vieta's formula. So, for example, if you look at here, come here. You ask the question, you're not focusing, mister. Let the root of this equation be UVW. So this is an equation. To put it in a polynomial-like form, this is z cubed plus 3 minus 3 roots minus root 3i, right? Is equal to 0. Right? This is more or less z cubed plus 0z squared plus 0z, then 3 minus root 3i. Equal to 0. Yes? So the sum of the roots of this equation, according to Vieta's formula, sum of root is equal to minus a what? N minus 1 divided by an. So what is our an minus 1 in this case? 0. What's our an? 1. So you have minus 0 over 1, which is equal to 0. Does that make sense? So sum of the roots is 0, which means if you had this, you get 0. Understand? So this implies that our u plus v plus w is equal to 0. Understand? Remember, they are the roots of this equation. So they satisfy that, we can describe it using that Vieta's formula. I'll go over it again. These are the roots from previous solutions. The next question says, by considering the sum of roots, the sum of roots, the roots are u, v, and w. Oh, this should have been small letters, my apologies, but I'm sure you understand. They're not capital letters. By considering the sum of roots, u, v, and w, show that this happens. You go back to the original problem, which is this. This is where you got your u, v, and w from. So u, v, and w are the roots of this cubic equation. Writing it as a proper polynomial equation, you can have this. If you apply the Vieta's formula, just like minus b over a in quadratic, all right, you get minus of this divided by coefficient here, and that gives you 0. The product will have been what in this case? 3 minus
root 3i.
Divided by the product is, can you remember Vieta's formula? Product is equal to negative 1 raised to power n a 0 divided by an. So because it's power 3, so that will be negative 1 raised to power 3. A0 is the constant term divided by 1. Okay, do we have the Vieta's formula in the formula booklet?
Yes.
So then you don't have to worry. Are you sure we do? Oh, here is it. Okay, so nothing to memorize. Sum and product of root of polynomial equation. Okay, having said that, let's move on. So we don't need the product. You just say by considering the sum of the roots. So we focus on the sum of the roots. So which means, what this means is that exponential, no. Let me write here. 12, 1 over 6, exponential that, plus 12, 1 over 6, exponential that, plus 12, 1 over 6, exponential that, is equal to 0. Yes? I can divide through by 12 raised to power that. Why, Karen?
Because
I can divide by this to make it easier. Why?
it's the same, like appears.
Yeah, apart from
It's a
because
constant?
it's non-zero. It's a non-zero constant. So if you divide by that, you're going to get exponential. These are not the same, so I can't just say divide by exponential something. Understand? Besides, this is a complex number. You don't want to assume that there's no zero somewhere, even though it can't be zero. You understand my point? So, we can use what? We change it back to,
Euler
this is your Euler form.
form. Change it to the CIS.
The CIS. What form do we call that? The polar form. We have the Cartesian form, which is A plus B something I. The polar form, the CIS format. Then exponential form, R exponential something is the Euler form. So you change it to the CIS. What in the question can be a clue that that is the form I need to change it to?
Because it has cosine.
It has cosine. So that's the message for you. Alright? It has cosine. So this is going to be, CIS means cos plus I, right? So this is going to be cos 5 pi over 18, which is right there, plus I sine 5 pi over 18. This is cos minus 7 pi over 18, which is not there. You're going to tell me why and what we can do to achieve what we want to achieve. Third one, cos 17 pi over 18, which is right there, right? I sine 17 pi over 18. Everything is equal to 0. Now this 0 can be written as 0 plus 0i. So I can consider the real part and the imaginary part. Maybe before then, I can write, this implies cos 5 pi over 18, cos negative 7 pi over 18, cos 17 pi over 18, then I bracket, understand? Sine 5 pi over 18, sine negative 7 pi over 18, sine 17 pi over 18 equals to 0. So in here you can write this as 0 plus 0i. So I consider the real part only. Okay? Considering the real part, if I consider the real part, I get, it implies that cos 5 pi over 18, cos negative 17 pi over 18. Clarissa, ready for my next question?
Wait, Mr. Darnell.
1 sec, sir. Have I made
Negative
this?
7 pi over 18.
This one?
Yeah.
Oh, thank you, sir. Clarissa, looking at this, do I have exactly what I want? What is wrong?
That's a negative sign.
So what do we do? If you're doing this, what will be your next line of action? I give you a few seconds, then I go to Krista C. Let's try Krista. Nice one. You spotted the missed problem. Do you have a solution, Krista? Brandy. Krista, okay.
Cos is even function.
Thank you. Cos is an even function. So what does that mean? It means cos minus theta is equal to?
Cos theta.
So the minus is absorbed. since cosine is an even function, wonderful. Love that explanation. It implies cos 5 pi over 18 plus cos 7 pi over 18 cos 17 pi over 18, everything is equal to 0 as required. Okay? Answer your question? Thank you, sir. Thanks for bringing that up. I'm sure we learned one or two things. Please bring up questions, especially in the last few days of our together. Not like together, we're going to be together for as long as we can. Now, let's look at this. This is the last one. Major problem with some of you, I don't get why you cannot take your time to do the needful, even if it looks like a waste of time. Okay, so let's look at the first part of the question. The function is defined as that. Anyway, trying to maximize my view. I hope we can see it on the camera too. It's okay. So we don't waste time. 12. We have f of x equals exponential sine x. The first one, find the first two derivatives. Easy. First derivative, what's the derivative of exponential? You copy and paste, then you differentiate the power. Right? You copy and paste first. Right? You remember? If you copy and paste exponential sine x. Differentiate sine, you get cos. No need to try to, memorize. Even if you write cos, check your formula booklet. Did I write the correct derivative? It's there. Okay? It's better you waste time fast checking yourself and getting it right than try to rush. Oh, I don't want to lose every 20 seconds and write rubbish eventually. Okay? It's better you do 7 out of 10 correctly than you want to touch everything, ended up having 5 correct stuff. So always just quickly look at your formula booklet. Did I use the correct derivative? Did I use the correct formula? That's the problem with some of us. It's in our formula booklet, we are writing the wrong version, applying the wrong version. Okay? Now, this is our that. Second derivative. It now becomes product rule. Because you now have two functions of x, not a constant and a function. So, I'll use my u, I'll differentiate one, copy and paste the other. Okay, with a plot. So, if we copy and paste this, we will differentiate this. Derivative of cos is minus sine. Plus, this is the one we copied and pasted, right? This is the one we differentiated. So this time we will copy and paste this. Then we will differentiate this. Which is, differentiation of this is just like the first one. You copy and paste first, times derivative of the power. Understand? So you're welcome to write it properly. Some of you did not, no problems. This is cos squared x. The reason I will appreciate this is because we're going to differentiate again, so you really don't want something too complicated. You're welcome to write the substitution immediately because we want to expand, right? So from here, you can say this implies that f prime of 0. Of course, here also we are going to do f of 0. Exponential sine 0, which is equal to exponential 0, which is 1. This will be exponential sine 0 times cos 0. This is exponential 0 times 1. 1 times 1, 1. So f prime of 0 minus sine 0, exponential sine 0. This is going to be 0, so this is gone. Then this is cos 0 squared, exponential sine 0. So this is gone. So you have 0 plus 1 squared times 1, so which is 1 also. Understand? Now, let me tell you another problem some of you made. State the Mclaren series formula. That alone is some points. Some of you didn't state it. And the mark scheme requires that I give you something for saying that. I'll show you. Okay? So let's take the Mclaren series together. Like Mclaren series, or from, you don't have to write the name, you can. You don't have to. From f of x is equal to what? F of 0, right? Followed by f. Talk to me, please. X. Yes. X, f prime of 0, x squared over 2 factorial, f prime prime of 0. It says up to x and including the x squared term. So don't go beyond. Just put dot dot for the rest. Okay? This implies f of x, our f of x is exponential sine x. F of 0, 1. X times 1. X squared over 2 factorial times 1. Dot dot dot. Which is equal to 1 plus x squared over 2 factorial. Is that what we got? Yes? Is that what we got? Okay. Let me show you how the marking is done. Attempting to use chain rule to differentiate. Remember, the first one is chain rule, right? For me to see that, oh yeah, you are using the right one, it doesn't have to even be correct, which means if you had written exponential sine x times sine x, I notice you are trying to use chain rule, but maybe you wrote the wrong derivative here. I can give you the one, the m1. But I see exponential sine x times 1. That's not chain rule. I don't know where that comes from. Do you get my point? Attempting to use chain rule for the first derivative, that. For getting the exact derivative, 1. Attempting to use product rule for second derivative, that. For the derivative, that. You see, all equivalent, which means you don't have to write it in this form. You don't even have to collect the like terms. Some of you did not. It's fine. Then, attempting to find this. So if I can find this, that is, oh, maybe you put this here, you put this here, I can see what you have done. It doesn't have to be together. I give you the one. Okay? You see, attempt is this, getting the exact answer. So there are 2 points there. Some of you don't even bother to show these workings. Then look at the funniest part. Substituting into the Mclaren's formula. Can you see this? A lot of you skip this. And all you have to do is copy from your formula booklet, isn't it? Some people jump straight to here. So they lost this point. Okay? Your mathematical communication is very important. I've always said that. After your IGCSE, I've been saying the same, that you cannot escape this. You need to communicate properly. Understand? Okay. Quickly. Then the next one. Show that the coefficient of x cubed in the Mclaren series is 0. According to our formula, our Mclaren series is this, right? Okay, there's no x cubed involved. But we know it's going to be x cubed over 3 factorial f prime prime, right? So that f prime prime divided by 2 factorial is the coefficient. Am I making sense? And the moment this is 0 itself, it means the coefficient is 0. So all you have to do, it suffices to show that the third derivative at 0 must give you 0. That's what they're asking you to do. And I think that's what most of you did. Wonderful. So to find the third derivative, we go back to the second derivative. This is where this format might be helpful. So you don't have, cos here, and you have 3 functions. So this is where this is helpful. And of course, you can use their own format too. When you collect the like term, you have, 2 stuff. So do you prefer this or I collect the like terms like they do? Let's just go with this. So we do f prime prime of x. Now this is product rule. Keep one constant and differentiate the other, then interchange again. If I copy and paste this, I have minus sine x. Then I'll differentiate this. It means copy and paste first and differentiate the power. That is one part. Then again, this is the one I copied and pasted. This is the one I differentiated. Now I will copy and paste this one and differentiate this one. If I just copy and paste this one, exponential sine x Now if I'm going to differentiate minus sine x, I get minus cos x. Minus will remain, sine will give me cos. There's no minus in derivative of sine. So that's the first part. Now the second part. So this is the black one, so I use red for this so you can easily pick it. The second part, I copy and paste cos squared. It means don't touch it, don't differentiate it. Then I differentiate that. And that gives me exponential sine times cos. Now I'm going to copy and paste this one and differentiate this one. So exponential sine x. To differentiate cos squared. Cos squared, this is the problem with some of you. Cos squared is this. Do you agree? So this is chain rule. It's like having 2x plus 1 raised to power 10. You bring 10 to the back, you change the power to 9, then you differentiate the bracket. Remember the chain rule? That's what you're supposed to use. So your cos square is that. So let's differentiate cos square. So 2 first, then it will be cos raised to power 1, right? Then times derivative of cos, which is negative sine. Hope I'm not too fast. I'm trying to, do something before the end of time. Understand? Again, you don't have to collect like terms. You just want to show that it's equal to 0, right? So just substitute right away. At 0. Of course, minus sine 0 is 0. So the first one is 0 automatically. Or you can just write maybe minus 0, exponential 0. Do you agree? Can I quickly do that? Okay. Oh, this will be times what? Come on. Times what? 1. And exponential 0 minus what? 1. And here, the red part. When you substitute x equal to 0, what do you get? 1 squared exponential 0 times 1. Then exponential 0 times 2, 1, 0. Okay? So clearly, this is 0 because of the 0 factor. This is 0 because of the 0 factor. You are only left with, on this side of the black, minus exponential 0. And on the side of this one, plus exponential 0. The rest thing are 0. Okay? And that is easy. Minus 1 plus 1, which is 0. And that's what you want to show. Therefore, coefficient of x cubed is 0. Quickly. Now, this is where some of you mix things up again. We can see the notes in the video, right? I don't need to take a picture. Do I need to take a picture? Anyone want to take a picture? Or you just check the notes on the... Or you can take it now. You can quickly take it if you want to. So quickly rush C and D. Done? Thank you. All right, quickly, about 10 minutes, 12. Using the Mclaren series of arctan and exponential minus 1, you have, even the series have been stated. You go to your formula booklet, you find arctan. Can we see? From arctan, x is equal to x minus x cubed over 3, x to the power 5 over 5, and so on. Then exponential. Now it says exponential what? Exponential x minus 1, right? Exponential 3x. But you don't even have that yet. So what other Mclaren series did you need to use? Exponential x, right? And exponential x is what? 1 plus x x squared over 2 factorial, and so on. It's in your formula booklet, no need to memorize. That's it. Okay? So from here, I expect you to find exponential 3x minus 1. You can first find your exponential 3x if you want, or you can do exponential 3x minus 1 directly. Do I do exponential 3x first and minus 1? Or you can just say this. So this is 1 plus 3x. This is 3x squared over 2 factorial, and so on, right? Which is going to be 1 plus 3x plus 9x squared over 2, like that. This implies that exponential 3x minus 1, only this minus 1 will be affected, is equal to 3x, 9x squared over 2, and so on. So you have these two. So we're going to make use of this and this. And the question says, find the Mclaren series of arctan of exponential 3x minus 1. Arctan exponential 3x minus 1. Arctan x is exactly the x. In this case, the x is this. 3x plus 9x squared over 2. Okay? Then minus, instead of divided by 3, I could put 1 over 3 first. Are you with me? Then I have 3x plus 9x squared over 2. Then I have raised to power 5. But up to where? Up to x cubed. I don't have business with raised to power 5. Because if I use x to the power 5, the least here would be 3 raised to power 5, x raised to power 5. That's the least power, right? And even the least is greater than what I need. It says up to and including x cubed term. So you don't need x to the power 4 and x to the power 5, so there's no need to include this. So all you have to do is just put the dot. Understand? So this would be 3x, 9x squared over 2. It continues. 1 over 3. Now we expand this. Remember, this has cube, right? Right? So, but even the cube, the least it can produce is 3x and the cube term. This is power 4, so we don't need that. So we only need to focus on this. Am I making sense? So we're going to have, oh, I forgot something. Okay. So let's expand this. We are going to ignore the others and just focus on this alone to power 3. So let's pretend it's a binomial because others are irrelevant now. So using your binomial, it's going to be this cube, remember? A plus b to power 3 is equal to what? Together?
Is
A cube, 3, a squared b, 3, ab squared plus b cubed. So cube of this.
27x cubed.
So we can, okay, maybe we write it like this first. 3x, of course, then 3, followed by, you see, immediately there will be what? Power 4. You can actually ignore that. Okay? So if you look at it, this is going to be 3x cubed. This, we want this. This is going to be 3x squared and what? Oh yeah, we need this too. Can you see? We need this too. So let's write quickly. So I have what? No, we don't. Hello? This is 9 over 2x squared, right? This is power what? Power 4. We don't need that. The next one will be 3x, 9 over 2. In fact, the moment you don't need this, you don't need the rest. So this is going to be squared raised to power squared, right?
Yeah.
So that gives you power 4, power 1, power what? 5. And the last one will be power 6. So this is actually the only term we need. So the rest, if you think about that, just put 3 dots like this. Am I making sense? So we collect only the like terms that we need. You understand this? Brandy? You're sleepy. Dude. You have the lots to catch up with, don't sleep. So we're just going to collect the reasonable like terms. I hope we don't miss anything.